Hello friends, hope you are having a fantastic day today. So now we are going to solve an awesome LeetCode problem called partition equals subset sum. Now we can see that this one is a LeetCode medium problem and also an extremely well-liked problem. So let's understand the problem statement. Basically, we are given an integer array called nums. Now we need to return true if there can be a partition in the array such that the two subsets that we make with that partition has the sum that is equal of the sum of the elements in both the subsets, and if that is not the case, then we need to return false. Now I know that the wording of this problem is actually not the best way to put the problem statement, but let's try to understand in simple terms. We are given an integer array. Now we need to, if we can create two partitions such that sum of all the elements in this partition and sum of all the elements in this partition, if both are equal, then we need to return true. If that is not the case, then we need to return false. Now let's try to see some examples. If we see this first problem, we can see that there are four elements and we can create a sum like this, that is sum of 5 plus 5 plus 5. So this can be one partition, and second partition can be this value 11. And if we check the sum of both of them, they turn out to be 11. So in this case, we can return true, that we can create a partition such that the sum of all the elements in both the partitions are equal to each other. Let's try to take one more scenario, 4 3 6. Now in this case, we cannot create a partition where the sum is going to become even. If we create a partition like 4 and 3 and second partition is 6, then it doesn't work, because this is going to be 7 and this is 6, and there are no other partitions that you can make. So in this case, you will need to return false, because no such partition can be made. Next, let's see one more example. So in this case, we can create a partition like this, 1 2 and 3 as first partition and second partition as 6. If we do sum of like either partition, eventually we would get the value 6 as the answer, and this is what we need to return. Because we are seeing 6 partition being made, we need to return true in this case. Now if we see the brute force approach for this problem, it is quite straightforward. Brute force, or the most simple way to solve this problem, would be to check for every single possible partition. So we can start from the first element and we can try to start every single possible partition. So we can create a partition where one value only contains 5 and the other value contains these three values. Then we create a partition like this, then we can create a partition like this, and so on and so forth. So every single time we would try to create all the possible partitions, and then we will see that whether that approach works or not. But the thing is, this is not the most optimal approach. Why? Because we can clearly see that with the given number of elements, we can create multiple partitions. So this basically becomes like an exponential time complexity, because now we are dealing with all the permutations and combinations. So this is not a good way to move forward with this approach. We will have to find a better way to deal with this problem. So the brute force solution would not work. Let's try to see that what the optimal solution would look like. Now, before we start understanding optimal solution, let's make 2 or 3 very quick assumption that will help us eliminate lot of bad cases. Number one thing is, whenever we are able to make like two equal partitions, there has to be the total number of all the sum has to be even number. What do I mean by that? Well, if the sum is even, then only we can create two partitions that are going to be equal to each other. And we can understand it with this example. We have three values, 1 plus 2 plus 3. So total sum is going to be 6. And because this total sum is 6, we have the possibility of creating two partitions that becomes equal in value, that is going to be 3 and 3. If we had the total sum to become even number, let's say that this value is 1 2 and 4, something like this. If we have an input array like this, if we do total sum, this becomes 7. With 7, we can never create two partitions that are going to be equal to each other. Why? Because 7 divided by 2 is going to be 3.5, and we are only dealing with integer numbers. So we cannot have a partition that sums up to 3.5, which means we cannot generate the answer. This is the first assumption we can make, that the total sum of all the elements has to be an even number. Okay, after determining the even number, next assumption is that once again for the same example, we can see that the total sum is 6. Now the total sum is 6. We know for a fact we need to create two partitions, and both partitions has to be even. So both partitions has to be valued 3 and 3 in nature. So in this given input array, if we can find a partition that sums up to only value 3, then we don't have to find another partition. It has to exist inside the array. Why? Because we know that the total of all of these elements are 6, and if we already find a partition, let's say with these two values, that sums up to 3, then we must have another partition that is going to be 6 minus 3. So this is also going to be 3, so we can also find that answer. So basically we need to first check that whether the sum is even number, and second thing we need to check is that are we able to find a partition that can actually sum up to the total sum. So total sum divided by 2. If we are able to fulfill these two conditions, then we can return true immediately, and if we cannot fulfill these two conditions, then we can return false in the end or immediately. Okay, now let's try to see the solution I'm proposing. And for that, remember one thing, that the input we are currently given, we are actually depending on the previously calculated values that we already have so far. Which means, let's say that if this is the example we are given, we know that we can make a partition with these two values as partition 3, but this is useless information if we don't know that what other values are or what is the total sum. We know in this case that the total sum is going to be 14. So because total sum is going to be 14, we are striving to create a partition that sums up to value number 7, but with these two we can only create 3. So should we discard them from the partition? Yes, but we can have another partition like these 3 values that sums up to 7. But the thing is, creating partition depends on the previous elements that we already have calculated and the next future elements that might come into the picture. So our current calculation that we are doing for the current value is actually dependent on previously calculated values that we already have, on whether to include that inside our solution or not to include that. So we are going to use the most beautiful thing in the entire computer science, that is dynamic programming. And for dynamic programming, what is the approach I'm suggesting? Number one, we are going to create a new dynamic programming array. But for this array, we are not going to go to the full length of the total sum that we currently have. We are only going to go up until the total part, like the half of the total sum. So currently half of the total sum is value 7. So we are only going to have 7 entries inside our dynamic programming array. We can create a partition array like this. Now initially all of the values are currently going to be false because we cannot create any single partition so far, because we haven't checked for all the values except value 0. Why value 0? Because we can always create a partition that equals to 0 if we don't have any value in that partition. So the purpose of this dynamic programming array is that for every single element we will only mark it true if we can create a partition that sums up to this value. So let me just mark the initial value as 0 as true, because we can always create a partition with 0 entries in it. So now this one is currently true, and our aim is to check that by the end we are done with all the current numbers that we have. We simply have to check that whether the DP of 7 is true or not. If this is true, then we can always have a partition that sums up to 7, which means we can create 2 equal partitions that sums up to 7 because the total is 14. So I hope my explanation made sense. Now let's see the walkthrough of this problem. So first thing we are going to do is, now we currently have value number 1. The idea is we are going to be starting from value number 7 and we are going to go back to the value number 1. And currently our I value that we are dealing is going to be the current I that we are using to iterate over all of these values. And next thing is that for the number that we are currently using, so we are actually using value number 1 to go over. So all we need to do is that dynamic programming value of any particular number depends on the total number of position, like so I position I have minus the number value I have. So let me explain what I mean. So currently I minus num that we are going to check for any particular value. So let's say when initially the I is going to be 7. So if I have to update the value of 7, currently I have a DP of I minus num is going to be DP of 6. So DP of 6 is false. So I'm going to leave this false. Same way for DP of 6, I'm going to be checking DP of 5. This is also false. Then for this one, because currently the number is 1 that we are dealing with. Same way this is false, this is false, this is false, except when we reach to this very first element, we can see that dynamic programming for 1 is going to be the value of I minus num. So the value of I is currently 1 and the value of num is also currently 1. So this is going to be dp of 0. So dp of 0 we know is true, which means we can also create a partition with that sums up to value number 1, and we can mark this as true. So let's just quickly do this one, and this is going to be turned into true. Now you understood what I did. I check for all the possible values and I check that whether there can be a partition being made where I can include value number 1, and then I can make those partitions. So currently I don't have any values, so I can not check any other value apart from creating a partition that is 1. Now let's start to work with value number 2. Once again we are going to be repeating the same formula, that we are going to be checking of dp of I minus the current number that we are dealing with, and current number is 2. So for value number 7 I will have to check dp of 5. So this is false, so I'm going to leave it as it is. For 6 I'm going to check 4, this is also false. For 5 I'm going to check 3, this is also false. But now for 4 I'm going to check 2, this is also false. But for value number 3 I'm going to check dp of 1. I now notice that dp of 1 is true, so I can also mark this as true, because I can create a partition using value number 2 that sums up to value number 3. So I'm going to be marking this as true. Now for dp of 2 I'll have to check value of dp of 0. So this also becomes true, so I can also mark this one as true as well, because I can create a partition that sums up to 2 which only contains one value. Now you must have gotten the grip of what we are trying to do in this problem. So now let's just quickly walk through the remaining solution. For dp of 4, for value number 7 I will have to check the dp of 3. dp of 3 is true, so which means we can also create dp of 7 is equal to true as well. So I'm going to mark this one as true. Same way for dp of 6 we will have to check dp of 2. So this is also true, so we are going to be marking this as true as well. And now you understood, for dp of 5 this is also going to become true, and dp of 4 is also going to become true. So this entire array eventually became true, and we haven't checked the value 7, but we can also check for value 7 as well. No worries with this one, and this is also going to become true. So now logically all we need to check is the dp of 7, if that is true or not. Since this is true, so in the answer we can also return true, saying that we can create a partition that sums up to value number 7 using this dynamic programming approach, and this is what we need to return. So basically this is such a beautiful solution, and rewatch again if you did not understood, and let me know in the comments on how do you feel about my explanation. Now let's try to understand the time and space complexity. In this case, time complexity is going to be big of n, because we are simply iterating the entire array, but we are doing it in total number of elements that are currently present inside the array. And if we see space complexity, so space complexity is going to be big O of n, because we are using an additional array to store this information. Now let's quickly see the coding solution for this one. So the coding solution is quite straightforward. First, we are going to initialize a variable called total sum, and we are going to iterate over the given input array nums and add all the elements inside the total sum. First thing we are checking is that if the given total sum is odd, then it is not possible to create equal partition, so we can simply return false. If that is not the case, we will first of all create the target value of which the partition number we are trying to achieve. Then we are going to initialize a boolean array called dynamic programming, and we are going to be marking the first value inside the dynamic programming array is true. Now notice that I added the value to be target plus 1, because if the target is 7, we need total 8 elements inside the array, where first element is going to be dp of 0. I hope you understood that. Now next thing is that we are going to have a for loop that is going to iterate over every single number that we have in the nums array. For each of the number, we are going to be checking that we are going to be starting from the target value, and we are going to go down to that particular number, and we are going to be reducing one element at a time. And every single location we are going to check inside the dynamic programming array that what is the value of j minus num, and if that value is true, then we can also define the dynamic programming of j to be true as well. And in the end, we simply need to return dynamic programming of the target value, or the very last element inside the given array. So this is the whole solution. Let's try to run the code. Seems like our solution is working beautifully. Let's try to submit this code. and our code beats 94% of all the other solutions in terms of time complexity and 87% of all the solution in terms of space complexity. This is one of the most accurate and beautiful solutions out there. So I would be posting this inside our GitHub repository. Feel free to go ahead and check it out. Thank you.